this is Scholar Chef doing some math today. In Algebra 1, we're going to be comparing linear models, which are our straight lines, y equals mx plus b, our exponential functions, which is a times b to the x power, and our quadratic functions are u-shaped, y equals ax squared plus bx plus c. Example 1. Use a graph to tell whether the ordered pairs represent a linear function, an exponential function, or a quadratic function. So, part A, just plot our points here. -1, 1, or -2, 7, 0, -1, 1, 1, 2, 7. So this looks like a U shape, and we can tell because it's symmetrical. This is a quadratic function. Part B, so -2, 4, -1/2, 0, 1. Looks like everything is decreasing by a half each time. That is an exponential. It's like sliding down a hill. And then our last one, -2, 5, -1, 2, or -1, 3. Wait, 5 is here, and 3. Then 0, 1, 1, -1. Okay, this one is just a line. So this is a exponential, and a linear. Okay, so that's one way to do it. We can graph it, see what it looks like. Example 2, we can either use differences or ratios. So if we look at the difference, so we have, for our x values, we have 2, 1, 0, 1, 2. But if we compare our y values, our outputs, we have 12, 8, 4, 0, 4. How do I get from 12 to 8? I subtract 4. That's my difference. 8 to 4 is another -4. 4 to 0, I minus 4. 0 to 4, that's a -4. When your differences are all the same, that is a linear function. All right, part B. We're gonna look at. We can easily tell that the differences are not going to be the same, because the difference between 0.25 and 0.5 is 0.25, but the difference between 0.5 and 1 is 0.5. So those are different. So we're going to look at the ratios, and by looking at the ratios, we're going to put the second number over our first number, and that's going to give us 2. Okay, and then for the next one, so the ratio of 0.5 over 2.25 is 2. The ratio of 1 over 0.5 is also 2. 2 divided by 1 is 2, and 4 divided by 2 is 2. So I'm just taking the next number divided by the previous number. So all these ratios are the same, so therefore this is an exponential function. All right, check point 1. Okay, so I'm going to just do my outputs only, but if you want to make a table, you can, so we'll do that. So -2, -1, 0, 1, 2. Let's take a look. So we have negative 1, 1, 3, 5, 7. If we look at the differences, from negative 1 to positive 1, that's plus 2. 1 to 3 is plus 2. 3 to 5 is plus 2. 5 to 7 is plus 2. Since all the differences are the same, this is a linear function, a straight line. Okay, let's look at the next one. So we can tell that the differences are not going to be the same. And the ratios are not going to be the same either. So how do we figure this out? So if we look at this closely, we can see that the left of the 0 looks exactly like the right of the 0, which means we'll probably have a quadratic going on. But how do we prove that without graphing? We do that by showing that the second differences are the same. So what are the second difference? The first difference is we find the difference between here and here, which is negative 2.25 difference. And then this is negative 0.75 to get from 0.75 to 0. To get from here to here, we add 0.75, and then we add 2.25. Okay, those are all different. So it's definitely not linear. The ratios are not the same, so it's not exponential. To show that it's a quadratic, the second differences have to be the same. So you take these two values, and let's use a different color. The difference between negative 2.25 and negative 0.75 is a positive 1.5 difference. From negative 0.75 to positive 0.75, we need to add 1.5, and then same thing. So because all the second differences are the same, this is a quadratic function. Alright, example 3. Tell whether the table of values represents a linear function, an exponential function, or a quadratic function. Alright, here we go. Well, we can easily tell right off the bat that the differences are not the same. If we look at them, this 32 minus 8 is 24, 8 minus 2 is 4. Those don't match, it's not going to work. And it doesn't look symmetrical. So we're going to find the ratios of all these. So the first one, 32 and 8, we're going to put the second number over the first. This reduces to 1/4. Okay, and then we're going to do these two numbers. 2 divided by 8, that is also equal to 1/4. 0.5 over 2 is also 1/4. And last but not least, 0.125 goes into 0.5 4 times. So how the next number is obtained is we multiply it by a fourth. 32 times a fourth is 8, times another fourth is 2, times another fourth is 0.5, and so on. So this is known as an exponential function. Write an equation for this. Okay. So this is y equals checkpoint 2. Oh, checkpoint 2. So this is a quadratic function. So y equals ax squared. So we're going to take one of these values that we do know. I'm going to use 1 and 0.75. You can use any of the points that they gave us, and it would work. But I'm going to substitute 1, 0.75 into our equation. So that's our x and y. So 0.75 is equal to a times 1 squared. That means a equals 0.75. So my equation is y equals 0.75 times x squared. And we're done. Hope you have a good day. See you later.